All right, guys, welcome to the first video of Precal. Just a good review from Algebra 2 here. Hopefully you know all this stuff already, but just a quick review, make sure that you do. So here we go. First of all, different types of numbers. These are, if you notice the title a minute ago was real numbers, so every number you're going to see today and tomorrow are real numbers. And there are several types of real numbers, and you've heard of these before. The first type is called rational. Rational numbers are numbers that you can write as a fraction. Any number you can write as a fraction, a whole number is rational. Decimals that stop or repeat are rational. Good examples right down here in this box. Integers. Integers are positive and negative whole numbers. You can see these right here, the purple box. -3, -2, -1, 0, 1, 2, 3. It keeps on going and going. Notice no fractions, no decimals in the integer. Every integer is also rational. A whole number, there's not a box here. The whole numbers start as 0 and then go 0, 1, 2, 3, 4, 5. So just positive ones and 0. Whole numbers, no fractions, no decimals. Natural numbers are numbers that you naturally count by. So they begin at 1, 1, 2, 3, 4, 5, 6. You can see the box right here beginning at 1 and going on. Again, no fractions, no decimals. So if it's a fraction or decimal, it's rational. Now the opposite of rational, of course, is irrational. Irrational numbers that do not repeat or do not stop. Pi is the most famous one in the world. The second most famous one is E. Also, any root, any radical that doesn't come out even, like square root of 3, cube root of 2, square root of 5, all those are irrational because they do not come out even, and they never repeat and never stop. Properties, 3 big properties we use in algebra all the time. Commutative. Commutative means the order doesn't matter. If you add or you multiply, the order which you do things, it does not matter. That's called commutative. Notice there's no N in the word. It's not commutative, it is commutative. The associative property is when you change grouping symbols. The order of grouping symbols does not matter. When you add, also, it works with addition and multiplication. You can group things different ways, no matter how you do the order, and it still works. And the last property is distributive property. That's the one you use most in algebra, where a number outside of parentheses, you can take it all the way through the parentheses by multiplying everything inside if you have addition or subtraction in your parentheses. That's a lot of words. And you've seen all that before. You should know those are the big 3 properties that we use the most. All right, this may be a tad bit new. This is called set terminology. If set S includes 1, 2, 3, 4, 5, if set T includes 4, 5, 6, 7, and set V includes 6, 7, and 8, it says find S. It looks like a U. That means union. And union, the union symbol, the big U there, actually means to put everything that they both have all together. So if I'm looking at one set S and T, they have a 1, a 2, a 3, a 4, a 5, a 6, and a 7. That's basically combining set S and T, everything that they have. Now when you see the second symbol, the upside down U, that means intersect. Where do S and T intersect, or what do they have in common? So if I'm saying where does S intersect T, what is the intersection of set S and T? They both have a 4, they both have a 5, and that's all. That's the intersection. And there's one more here. Notice it's an upside down U again, which means intersection. So where does S intersect set V? And S goes through 5, V has 6, 7, and 8, so nowhere. So I'm going to use this symbol right here. That's the symbol for empty set. There is nothing in there. There's no intersection at all between those two. And that's okay. You did some of this in Algebra 2, but not a lot of it, so I want to review this real quick. What the notation means, if you see this, X is between A and B, greater than A, less than B, the graph on the number line has the empty circles. You might remember doing empty circles in Algebra 2. This is called interval notation, where we put A and B in a parentheses and use parentheses. Now, the other side of that is, what if there's like equal to there? What if it's X is greater than or equal to A and less than or equal to B? You now have filled in circles. If you have filled in circles or shaded in circles on your graph, we're going to use brackets. So everything between A and B, including A and B, that's how we would read that. It includes A and B. If you have 1 equals, you have 1 bracket. 1 equals sign, 1 bracket. If you just have A is less than X, your number line, X is greater than A. I read that backwards. X is greater than A. A has an empty circle because there's no equals, shaded greater than the A. And then what we're going to write that's A to infinity. Infinity always uses a parentheses because you can never get to infinity. All right, so 2 parentheses there because there's no equals. A is less than or equal to X, or X is greater than or equal to A. X is greater than or equal to A, so we're going to shade in the circle. And shade greater than, bracket because there's an equal to. X is less than b, empty circle with the b, shade to the left, that's where the less than is, and we go to negative infinity. You always go, when you write your interval here, we're always going to go look at our graph and go left to right. Okay, so we're going from we're shaded from negative infinity until we got to b. X is less than or equal to b, that's just a filled-in circle and a bracket. And if you shade the whole number line, all real numbers, we go from negative infinity to positive infinity. Again, no brackets, only parentheses with infinity symbols. All right, graph. This first one says, let's go ahead and make a little number line here. It says graph between 1 and 3. Now notice there's parentheses, so I'm going to put a 1 here, a 3 there, empty circle, because there's parentheses, so I would shade right there. Now it says intersects 2 to 7, right? 2 would be here, and filled in circle because of the bracket. 7 is over here, filled in circle. Now, technically I would shade between the 2 and the 7 just like this, okay, including the 2 and the 7, but it wants the intersection of the two. So the question becomes, where did I shade here and here? And the answer, where did I shade between those two? I mean, what's the intersection of the two is I shaded between 2 and 3, including the 2 and not including the 3, because 3 is not included in that set. So upside down, you intersection of the two. Now, part B, same question, except now it's the union. So all of it all together. So 1's here, empty circle. 3's here, empty circle. 2's here, filled in circle. 7's here, filled in circle. Now, I should have gone ahead and shaded. When I shade the first part here, between 1 and 3, it's right there. When I shade between 2 and 7, filled in circle there, all the way to 7. So union means everything they have in the whole thing. Like what all got shaded, everything they have in common, not in common, everything they have in each other set combining the two sets. So it means I'm shading from 1 all the way to 7. So everything you see in white right there would be the answer to that one. One more slide here, hang in there. All right, last one, absolute value. It says definition of absolute value. The real definition of absolute value is how the distance the number is from 0 on a number line. That's what it is. So absolute value is two ways you can do absolute value. The absolute value of A is A if A is positive. However, it's negative A, or the opposite of A. That's what the negative sign means, opposite of, if A is negative. If A is negative, the answer is the opposite of A. If A is positive, it's just A. Okay, so, for example, right here, the absolute value of negative 3, because it's negative, would be the opposite of negative 3, which is 3, because it's 3 units away from 0 on the number line. The absolute value of positive 3, because it's positive, is just 3. It's also 3 units away from 0 on the number line. 0 is a weird one. It's not negative or positive. How far is 0? How many units is 0 from 0 on the number line? 0. Okay, this is a weird one. Hang in there on this one. This is the last one I got to show you on the whole video. Absolute value of 3 minus pi. Now, some of you probably remember from geometry that pi estimated is about 3.14. So that means 3 minus 3.14 would be negative. And because it's negative, the absolute value of a negative number is the opposite of the negative number. So I need to find the opposite of 3 minus pi. So if I do the opposite of 3 minus pi, the 3 becomes negative, the pi becomes positive, and there you go. There's the opposite. There's the absolute value of 3 minus pi. All right, thanks for hanging in there. Can't wait to see you in class tomorrow. We'll work on some of these problems together. See you then. Way to make it through your first one.